Hello, students. Today we have another topic. We'll talk about exponential functions. Okay, why is it important to study about exponential function? The exponential function is very important in math because it is used to model many real-life situations. For example, population growth and decay, compound interest, economics, and much more. Here we have the definition of exponential function. It says here, f of x is equal to b to the power of x. Question, how is this function different from functions that we have worked with previously? Okay, here's the answer. The exponent is the variable. F of x equals b to the power of x. You have to take note that b is the base, and b is greater than 0, and b is not equal to 1. And x is the exponent, and x is any real number. Question, is f of x equals x cubed an exponential function? The answer is no, because in this function, the base is the variable x. It's not the exponent. Now we will have the different definition. An exponential function can be written as f of x equals b to the power of x, where b is greater than 0 and b is not equal to 1 and x is any real number. Examples. Number 1, f of x is equal to 3 to the power of x. The base is 3 and the exponent is x. So that's an example of an exponential function. Number 2, g of x is equal to 10 to the power of x. The base is 10 and still the exponent is the variable x. Number 3, h of x is equal to 2 to the power of x plus 1. The base is 2. So these are the examples of exponential function. Now we will go to the function that is not an example of an exponential function. Number 1, f of x is equal to x squared. The reason why that is not an example of an exponential function is the variable is the base and not the exponent. Number 2, g of x is equal to 1 to the power of x. Why is it that this is not an example of an exponential function? Because the base of an exponent of an exponential function must be a positive constant other than 1. So it should not be 1. Number 3, h of x is equal to x to the power of x. It is not an example of an exponential function because both the base and exponent are variables. So kindly take note that the domain of an exponential function is the set of all real numbers, and the range is the set of all positive real numbers. Okay, these are the properties of exponential functions and their graphs. Number 1, let f of x is equal to b to the power of x, where b is greater than 1 and b should not be equal to 1. Number 2, the domain is the set of real numbers from negative infinity to positive infinity. Number 3, the range is the set of positive real numbers, 0 to positive infinity. And number 4, if b or base is greater than 1, f is an increasing exponential function. If b is greater than 0 but less than 1, f is a decreasing exponential function. The function passes through the point 0 and 1 because f of 0 is equal to b to the power of 0, and that's equal to 1. Remember that any variable or any number raised to the power of 0, the value is always 1. The last is the graph approaches but does not reach the x-axis. The x-axis is the horizontal asymptote. So those are the properties of exponential functions and their graphs. We will go to the graph of an exponential function. One of the most common exponential function is f of x is equal to 2 to the power of x. So if we are going to graph that function, it looks like this. It's increasing. Okay, the graph starts off slow but then increases very rapidly. The x-axis is an asymptote, and x can be any real number. For example, f of x is equal to 2 to the power of square root of 3, and 0 and 1 is the y-intercept. Okay, I will ask you, what would the graph look like if b is between 0 and 1? For example, f of x is equal to 1/2 to the power of x. So 1/2 is between 0 and 1. So what would be the graph look like? So we have here, f of x is equal to 1/2 to the power of x. The graph starts off very high but then decreases very rapidly. The x-axis is an asymptote, and x can be any real number. For example, f of x is equal to 1/2 to the power of pi, and 0 and 1 is the y-intercept. So this is an example of models of exponential decay. Now to recap, the definition is f of x is equal to b to the power of x, and b is the base, and b is greater than 0, and b is not equal to 1. And x is the exponent, and x is any real number. So you look at these two graphs. At the left side, b is greater than 1, and at the right side is b is greater than 0 but less than 1. Now we will go to solving exponential equations. What shall we do if we are going to solve some word problems regarding exponential equations? Okay, question. What is an exponential equation? The answer is equation where the variable is the exponent. Example, 2 to the power of x is equal to 1/8. Now we are going to find what is this known number, a known exponent of 2 that is equal to 1/8. So what shall we do? How do we solve this? Any ideas how to solve this? Now, what if we change 2 to the power of -3? We will make 1/8 as base 2. Diba? 2 to the power of -3 is equivalent to 1/8 also. Now, we will equate. The left side of the equation is 2 to the power of x, and the right side of the equation is 2 to the power of -3, because 1/8 is equal to 2 to the power of -3. If we are going to change 1/8 to base 2, now what? You set the exponents equal. If 2 to the power of x is equal to 2 to the power of -3, then x is what? That is -3. Now we have to check if they're equal. 2 to the power of negative 3 is equal to 1/8. 2 to the power of negative 3 is the same with 1/8. Then we have solved 2 to the power of x is equal to 1/8. The solving exponential equations has 3 steps to follow. Number 1, express each side of the equation as the power of the same base. Number 2, set the exponents equal and solve. Number 3, check your answer. Now, the main idea here is the bases are the same, set the exponents equal so that we can solve the unknown number. So let's look at some examples. Solve for x. 7 to the power of x minus 2 is equal to 7 to the power of 3x. Now we are going to find what's the value of x so that the left and the right side of the equation will be equal. The question is, are the bases equal? Yes. And if the bases are equal, then you have to set the exponents equal and solve for x. So we have the exponent at the left side is x minus 2. At the right side is 3x. So we have to add to both sides. X minus 2 plus 2 is equal to 3x plus 2. So x will be at the left side and at the right side is 3x plus 2. Now we will combine the right terms. We have here x. We'll subtract 3x both sides. So x minus 3x is equal to 3x minus 3x plus 2. And then x minus 3x is negative 2x. And here is positive 2. To find the value of x, we have to divide negative 2 both sides. So negative 2x divided by negative 2 is x, and 2 divided by negative 2 is negative 1. So the value of x there is negative 1. Now we will check your answer if it's correct. So our value here is x is equal to negative 1. So we will substitute this negative 1 to the place of x at the equation. 7x to minus 2 is equal to 7 to the power of 3x. So we have 7 to the power of negative 1 minus 2 is equal to 7 to the power of 3 times negative 1. So negative 1 minus 2 is negative 3, and 3 times negative 1 is negative 3. So it checks. Left and right are equal. Example number 2. Solve for x. 5 to the power of 4 minus t is equal to 25 to the power of t minus 1. Are the bases equal? No. So we have to change the x to base 5 so that we can equate them. 25 can be written into exponential form. That's 5 squared because 5 squared is equal to 25 to the power of t minus 1. And then we will simplify. So we have here, the exponents are 4 minus t at the left side, and then 2t minus 2 at the right side. So we will subtract first 4 both sides. So we have 4 minus t is equal to 2t minus 2 minus 4. And then negative t is equal to 2t minus 6. And then negative t is equal to 2t minus 6 plus 6. We'll add, no. We will add t. 2t, we'll add 2t. Not add, but we will subtract 2t. So negative t minus 2t, and then 2t minus 2t minus 6. So negative t minus 2t is negative 3t, then negative 6. And we will divide negative 3 both sides because the number together with t is negative 2. And the value of t is 2. Okay, let's check your answer. So if t is equal to 5 to the power of 4 minus t is equal to 25 to the power of t minus 1. So we will replace the place of t with 2. So 5 to the power of 4 minus 2 is equal to 25 to the power of 2 minus 1. So 5, 4 minus 2, and then 2 minus 1 is 1. So it checks because 5 squared is equal to 25. We have our last example. Solve for x. 49 to the power of x minus 2 is equal to 7 squared of 7. Why x is equal to 11 over 4. How do we get this? Okay. The question is, are the bases equal? 49 to the power of x minus 2 is equal to 7 squared of 7. The basis is not equal. So we have change both sides to same basis. This 49 and we change it into exponential. So we have 7 squared. The 7 squared is equal to 49 to the power of x minus 2 is equal to 7 times 7 to the power of 1 half. Why? Because if you're going to change radical forms and that is square root, the value is 1 half. You're going to change that to exponential form. So we have to simplify. So 7 squared to the power of x minus 2. So we will multiply both exponents. So 2 times x is 2x, and 2 times negative 2 is negative 4. And then why it becomes 3 over 2? Because the exponent of the other 7 is whole number 1. And then we will add 1 half. So whole number 1 is the same with 2 over 2 if we will make same bases because they are not like fractions. So 2 over 2 plus 1 over 2, that is 3 over 2. And then we will solve. We have 2x minus 4 is equal to 3 over 2. Okay, we will add 4 both sides. First, 2x minus 4 plus 4 and 3 over 2 plus 4. So we have 2x at the left side, and then since 3 over 2 and 4 are different fractions, so we have to find their LCD. So we'll use 2 as the LCD. 2 divided by 2 is 1 times 3 is 3, and 2 divided by 1, the denominator 4 is 2 times 4 is 8. So 3 plus 8 is 11 over 2. So 2x is equal to 11 over 2. And our aim is to find the value of x. So we need to divide 2 both sides. So what's the principle again in dividing fractions? So we have 11 over 2 times the reciprocal of 2, which is 1. And we will multiply. So we have 11 times 1 is 11, and 2 times 6 is 4. Therefore, the missing x is 11 over 4. Okay, let's check. X is equal to 11 over 4. 49 to the power of x minus 2 is equal to 7 squared of 7. So 49 to the power of 11 over 4 minus 2 is equal to 7 to the power of 3 over 2. Because as we know a while ago that 7 squared root of 7, if we will make them as exponential, the result is 7 to the power of 3 over 2. And here, 11 over 4 minus 2 are unlike fractions. So we need to find their LCD again. So the LCD is 4. 4 divided by 4 is 1 times 11 is 11. And 4 divided by 1 is 4 times 2 is 8. So 11 minus 8 is 3. So that is why it becomes 49 to the power of 3 fourths is equal to 7 to the power of 3. So how we will apply the rule so that we will come up with the left and the right side be equated. So 49 is the same with 7 squared. And 2 times 3 fourths. Okay, let's have cancellation. 2 divided by 2 is 1 and 4 divided by 2 is 2. So 1 times 3 is 3 over 2. So it's 7 to the power of 3 over 2 is equal to 7 to the power of 3 over 2. Let's check. And we'll have a review. Again, the exponential function f of x is equal to b to the power of x. The b is the base, and b should be greater than 0, and b is not equal to 1, and x is the exponent, and x is any real number. The key point here, the exponent is the variable, not the base. Number 2, exponential equations. An equation where the exponent is the variable. So we have here, example, 2 to the power of x minus 6 is equal to 16. How to solve? Are they the same bases? No. So we have to change 16 to base 2. Since 16 can be written to exponential to base 2, so we can have write them as 2 to the power of 4x minus 6 is equal to 2 to the power of 4, because 2 to the power of 4 is equivalent to 16. Then we have to set exponents equal. So 4x minus 6 is equal to 4. And we have to add 6 both sides. So 4x minus 6 plus 6 is equal to 4 plus 6. And 4x will be at the left and 10 at the right. Since 4 is together with x, we will divide both sides by 4. The value of x is 10 over 4. Now we will check. 2 to the power of 4 times 10 over 4 minus 6 is equal to 16. And we will apply cancellation here. We canceled out 4 at the numerator and 4 at the denominator. So then 2 to the power of 10 minus 6 is equal to 16. And 2 to the power of 10 minus 6 is 4. So 2 to the 4th power is equal to 16. So it's check. Okay. Remember, students, that in an exponential function, we are the base and God is the exponent. If we put God as our exponent always, we will have a greater value always. So we need to put Christ as our top priority, because without Him, we are nothing. I hope, students, that you learned something today.